Today's podcast sponsor is Huber Engineered Woods. And I want to talk to you about zip sheathing and why we use zip sheathing. I know you've heard me talk about it on the podcast before, but I thought let's just lay it out in the simplest of forms. Number one, when I install it properly, I tape the seams, I liquid flash the seams, I manage for water with my windows. I use their products. I don't have to worry about water. There are times when we install drywall inside of a house and we don't have cladding on the outside because I know zip system is going to be waterproof. So that's number one. Number two, I can manage for air. So using zip system sheathing on the walls, my last 5 houses we built were all below passive house levels of air leakage. They were all below that 0.6 ACH50. And we're not putting that much effort into air sealing. We're just making sure that we tape well, which we manage for water, we manage for air. And the last 5 houses that I built all had zip R because that continuous insulation that comes adhered to the back of my zip sheathing that I'm already putting up and installing, now I have continuous R value that I get the whole R6 or the R9 or R12, whatever it is. I don't see building any other way. It works for us. It can work for you. Make sure you go to huberwood.com and check them out. And Huber, thanks for sponsoring the podcast.
Hello, UnBuildIt Podcast. Steve Basic live from the UnBuildIt Podcast studio. And today you are definitely in for a treat because we're all fired up because we're talking heat sources today. Got my good friend Jake, good friend Pete. Let's have at it. So, heat sources, guys. There's a whole bunch of them. Times seem to be changing. As an architect, I know that location probably decides some of this for me.
Mm-hmm. I mean, I'm not spending a bunch of money on heat if I live in Miami.
You're probably not spending a bunch of heat in Miami, but I was more targeting some places I have access to natural gas, some places I don't. Some places I can get propane, some places I can't. So those are all kind of parameters that fall into that. But the first one I want to talk about that I didn't even know if it was on our list is the one that Mother Nature gives us, right? The sun, which is available everywhere. And in Miami, of course. Yeah, a lot of the time. And then the interesting thing about the sun is that we can use it in its raw form, and we can have that raw form then transferred into some type of heating source, meaning electricity, right, via PV. So you really have, kind of this duo when you're dealing with Mother Nature. But I know the Roy house, when we did it, Dan measured it. 57% of his heating bill is taken care of by the sun, which I find pretty amazing.
So it's actually a really good point that you bring up, like that we are getting that heating source, but we're also most likely, if we're planning appropriately, using the design to also help with our cooling too, right?
Well, yeah, I think the design helps with our cooling and our heating. Yeah, if we do it right. It's a little bit of a challenge, but you have to understand, are you in a heat-dominated climate or a cooling-dominated climate? And then you kind of tilt your scale in favor of where you are. So knowing where you are is pretty important.
And don't we have trouble in really high-performance homes with shoulder season heat gain?
We do with heat gain, humidity in the summertime. So there's those things that we need to address also with the HVAC system. It's not quite the heating side, but it certainly becomes part of that equation, if you will.
Okay, so let's talk about some of the different sources. Let's start with the next most basic, if we're going to heat with wood.
Yeah. So I was always told, and being from the Vermontier that you are, I'm sure a lot of people use wood.
Let's clarify you're talking about Peter, but I don't want anybody assuming that I'm from Vermont.
No, you're a military basher from Missouri, so we'll leave you there.
Cheers.
But in Vermont, and honestly, for those that don't know, I probably grew up, I don't know, maybe about 70, 80 miles from where you live in roughly the same kind of country. And wood is big up there.
Yeah.
And wood is big up there because you can probably accumulate 2 or 3 cords of wood just by the trees that fall on your property and go out there, cut it up and use it. And that reminds me, just put a note there. I got to tell you about the most fascinating heating system I've ever seen. Yeah, and I got to
It's like burning cow dung or something?
No, although I so put a star next to that because I got 2. But wood, I was always told wood is probably the most inefficient heat source there is when you calculate all that you have to do for the BTUs that you get.
But if you're fancy yourself a hard worker, and you need exercise, there's romanticism in burning wood.
Because I had a client and he would get logs delivered. He would cut them, split it, dry it, stack it, and I said
he'd spend 10 weekends out of the year to have.
Wood is horrible. I told him switch to gas, go get a job at 7-Eleven on weekends, and you'd probably come out ahead.
Yeah, and at least while you're working at the gas station, you can talk to people. You don't have to wear ear protection and
But you're right. The people that burn with wood love burning with wood. So it's hard to change their mind.
And so regular fireplaces suck.
Yeah.
The code, literally. The code a few years ago, maybe 2012, introduced the idea that we have to have makeup air for a fireplace. So you have to port in a hole in the house. And, there's lots of times where if you're going to get a fireplace to draw, then you're opening a window to get the fireplace to draw. And chances are you're not lighting the fireplace when it's good open the window weather,
But I did do a high performance house, Windsor, heating degree days 6,800 up there, I believe. And we just put an addition on the house, but it was probably about a 1,500 square foot house. He would heat it all day and all night with 2 armloads of wood. In his wood stove, and it was a raised wood stove,
sealed high performance wood stove.
But it's a sealed one. But the chimney or the inlet was a PVC pipe that comes in through the bottom. The thing only takes, I don't know, it's cylindrical, probably about an 18-inch diameter, 20-inch diameter, and it's almost zero clearance. It's like 4 or 6 inches, so you can tuck it in a nook somewhere. And the thing throws off amazing heat.
But the problem with that is it's still a comfort issue because sitting next to that thing, it's burning hot, and down a hallway and into another room.
This is a wide open plan, and we HVAC, so we get a little stratification, but it works for them. It works for them.
But again,
distribution is always.
I want to heat with wood conversation. Nobody would go, oh, what's the most comfortable system
he has
I can get?
30 acres in the woods, and all he has to do is walk in the woods with a chainsaw, and he doesn't even have to cut trees down, just cut up the trees that fell down.
Well, since you asked about Vermont, it's really common for having wood heat. And the interesting thing is that when they pull people to switch to mini splits, which Efficiency Vermont is encouraging, there's a pretty good fit because when you get down to, -5 and lower in temperature, if you have a wood stove, that's a pretty good plan for when
It's an offset.
It's an offset. And so they've got a natural backup heating source if the power goes out or if it gets super cold. And getting Vermonters to give up their wood stoves is pretty challenging. However, what's interesting about this is, talking about other sources of heating, is that all the people that had wood stoves in their house never had any central cooling. And you put a mini split in, and now all of a sudden you've created a summer electrical peak because they weren't air conditioning their whole home until they got set up to be able to do that. So the peak demand in Vermont, there's a new winter peak because they've encouraged so many people to switch to electricity when they weren't using it before. And now there's a new summer peak because they were encouraging people to use it. And so it's a good segue
If you have it, you're going to use it.
if you give people additional thermal comfort as an option, they're probably going to exercise it.
Yeah.
Okay, so we're talking about burning things. Let's stick with the idea of we're burning things. CNG or propane. We have forced air heat like that. We have versions of almost kind of like radiant heat if you have point of view single room units.
It's arguable that one of the I don't know, advantages or pros of those is that you have multiple ways of heating from that source, right? Like wood, it's either going in a fireplace or wood stove or campfire. I mean, although
excluding
before we go off
heat,
of that, I just remembered the name. So it was a wood-fired emulsification furnace. I think that's what we called it.
Emulsification?
Yeah,
made that
it
up.
was something. No,
Wow.
It's something like that. But I just remember, I went and looked at a job, and he's like, "Hey, you got to come see what my friend is doing." So we go into this guy's basement, and it's usually for agriculture, and it's like this chambered wood stove that you heat. You can burn any kind of wood because it's all about the amount of air that you mix in with the wood and the way it gets drawn through this thing, that you can burn pine, spruce, anything.
You could burn kiln dried
Because
offcuts.
it burns so
And you're sure
hot.
it wasn't gasification because
It
all
might
of
have
the,
been it was some kind of ification, so maybe it was
Google
gasification,
that.
but
because the wood
Guys.
pellet boilers, which are very efficient, they do a second round of combustion with the gas that's created.
right. But he had all these like chains that opened up different valves so he could play with the amount of air. Like it seemed way more work than what it was to heat this
Welcome to
cake.
wood
Like
heat.
just put in a Braderas furnace or something there, buddy, and call it a day, right? Because this thing was about the size of a pickup truck with a hood on the back, so it was good size. But he was heating like 2,500 square feet with a half a wheelbarrow of wood every day. So
was it a boiler? So it was
yeah,
hydronic?
and he
heat distribution?
he heated the water for the system, but he also heated his hot water. He had a couple hot water storage tanks. But anyways,
So let's sidetrack real quick into that idea of like your furnace also like your boiler is your hot water and it's your hydronic heat. I know that's way more common where you guys are from.
Yeah. My house,
the
I
boiler
have
thing
that.
is not popular here. We only run into it every once in a while. I have a hard time with that. Like I have a hard time with, we don't have hot water and we don't have heat now. Like
Yeah, my
if something,
boiler
I
goes
hate
down, we
to
lose
combine
hot
things
water.
and we lose multiple things.
Yep.
I realize, if your furnace goes out, you have a problem. Your water heater goes out, you have a problem.
but the boiler is far more efficient than the hot water heater.
It is.
So
And so what's the alternative if you're all electric and the
Tent.
grid
You
goes
live in a
down?
tent.
Oh, you live in a tent. Okay. So that has no
I wish
heating
my
system.
wife would live in a tent. We would probably live in a tent.
So were you there when Mike Lodge worked at Building Science Corporation?
No, I don't remember Mike Lodge.
Okay. So he was a gentleman who worked at Building Science Corporation with us. He lived in a teepee. And when you sit there and say, "What teepee? What did you build this thing?" There, you can Google it. You can buy professionally made teepees. And he lived in, he like 40 acres. He would take his jugs of water home every day from Building Science Corporation.
I did June to February when I was 14. I worked at a summer camp over the summer, and I came home and the house was freezing because I'd spent the whole summer outside. And I said, I'm going to sleep in a tent. And my parents said, okay. And I think that they were like, oh, he'll be
won't
in once
last
it gets cold. And then in February, when I was like tracking snow in the middle of the night to go to the bathroom, my mom was like, it's time to put the tent away.
So there was just a really cool presentation that Candace Pearson did for the class I'm teaching this fall. And it was really interesting to look at the carbon profile of going all electric, depending upon what the grid was using to create the power.
Where you live and who's generating your electricity.
And a lot of the problem is that if you're doing any type of renewable energy, wind or solar, the generation during the time of day doesn't cover peaks. And so you may feel like you're net zero annually, but day to day, if the power being delivered is peaking at a different time than demand is peaking, you're still turning on really nasty power plants to
coal plant
cover
or
the
something.
peak. So it's really interesting to look at how we think of net zero annualized, like, hey, I'm covered. But in terms of power generation, it's all about daily cycles.
We can feel really good. The podcast studio here is powered either by wood chips or nuke power. So we have fairly decent.
So your carbon profile for your electricity is really, really clean.
Yeah.
Yeah, Vermont was like that between hydro and nuke until they shut the power plant down.
Vermont, Massachusetts, I mean, all of New England probably gets it's hydropower out of Canada, I believe, isn't it? Or a lot of it.
Well, it's a blend, but yeah, there's an awful lot of hydropower from Canada. Yep.
Okay, so we didn't really cover combustion in the form of, gas. So we're in agreement that unvented appliances, like a wall heater like my grandparents had, that my grandmother used to stand in front of, that's probably a bad idea because indoor air quality is a real concern then.
Yeah, these unvented appliances, which got into the code and we've had no success in extracting them, it's if they burn perfectly, then they're generating carbon dioxide and water and heat.
And I wonder how long after they leave the factory they quit burning perfectly, even if they did when they left the factory.
And, of course, if you have an indoor air quality monitor, you can see what the profile is. But even if it burns perfectly, every therm of gas burned, 90,000 BTUs, is a gallon of water. So is that a lot of water? Well, it depends on how tight your house is or how much you're ventilating.
How long you're running the heater,
I just did a building investigation on some multifamily units, and it's really interesting to look at the moisture profile where there's all of these units had gas cooktops, electric ovens, but wherever there was more than 3 people in a unit, the mold in their attic was double what it was for their neighbors. And then we went into one where a guy was living by himself, and as part of the, he happened to be leaving for work, and I said, do you run any humidifiers? Oh yeah, during the winter I run a humidifier in each bedroom. So what did he have in his attic? It was as much mold as the people who were cooking all the time. So those moisture generation rates, if you're not...
I'm trying to figure out why you ran 2 humidifiers if you lived alone.
2 bedrooms. A lot of people do it to protect...
Ping pong through the night? Like, I'll go sleep in there for a while?
No, it's protecting... I would say 50% of the times I go into a building where they're running humidification during the winter, it's to protect musical instruments. Pianos, guitars.
See, you thought that, but I was daydreaming about living alone. I'm like, he lived alone. Tell me more about this guy. Was he cool? Okay, cool. So right now we're not getting away from CNG or propane. It's too much part of our system. I think we would all just say, there's alternatives. Mm-hmm. You should be thinking about alternatives. And if you're looking at having a lower environmental impact, electricity might be the way, because I'm guessing propane and natural gas are going to continue to get more expensive. Maybe not this week, maybe not this month, but over the next 10 years, we're going to be paying more for propane, or our tax dollars are going to be paying for more subsidies.
That'd be interesting, because you could probably or see an argument that the use of it probably is going to go down, which means that the curve is going to flatten out. Meaning, you don't have that many people demanding it, or as more people switch to electricity, the demand is lower on that stuff, so that you're not going to have that much demand, so the price doesn't have a reason to climb. So, the holdouts win on that.
Well, and so we're talking about choosing heating systems. I just want to say that when I started working at the NHB Research Center, there weren't any cold climate heat pumps. They were horrible. Yeah. They went to strip heat because they just couldn't do the pulling the BTs out of really cold air. And I don't like forced air systems because they're noisy. But now we go to these mini splits, which deliver COPs, respectable down to below 0.
Yep.
And they're quiet. There's none of the cold blow.
Yeah. So we have one running in the studio right now, and you probably can't hear it in the background.
We now have cold climate heat pumps that are quiet. They're clean.
And we have a house that can take up some of the lag time, right? That we didn't have before either.
Yeah. We're not losing heat at the same
the
extreme
houses aren't
rate.
glowing. Like
But to
the
me,
house
it's
I grew up
completely
in.
changed the choices because a lot of the concerns that people had with heat pumps, they're way more efficient and they're way more reliable than they have been in the past.
So we run a Fujitsu heat pump at my personal house, and last winter in February we had 3 days that were -10 in a row, and we lost like 1 degree. The house was like starting to go, okay, are we going to have a hard time?
Yeah, I mean, we
keeping
have
up?
Mike Duclos has a house out in like Western Mass. They lost power for like 5 days, and I think they lost like 12 degrees in total.
But we could have
it was a passive
easily
house.
plugged in an electric heater.
Yeah, to supplement it, a little ceramic
big toaster
heater or something.
and got it back up.
Blow dry your hair a little longer in the morning. Well, you don't have any hair, but your wife.
I blow dried the part in the back, though.
There you go. So alternative systems other than solar, the other half of my equation there. I had a gentleman. We never built the project, but our plan was he had a whole bunch of horses and farm animals to encapsulate the manure and strip the methane off of it and burn it and pipe it. Burn it in an outbuilding and then pipe the hot water to the building, which we didn't get very far on it, but the view from 10,000 miles up was pretty cool anyway.
There's a program in Vermont called, of course, Cow Power, because we've got all these dairy farms, and there's been a number of projects where they capture all that waste, they gasify it to create the methane, and less pollution.
It's not hard to capture. I grew up working on a dairy farm, so it's not hard to capture. You can conveyor.
Take a lot of it home in your clothes every day.
Well, you just say it all gets conveyed out to a trailer if you want it to, right? And you spread it out. And there's a lot of power in that poop.
So let's go back to electric for a minute. So my personal house and a lot of the houses that we're building now, even though we have CNG or propane, or we can get propane delivered, we're pushing for combustion free. Mm-hmm. Number one, for that air quality concern. But number two, I think that the house can be more efficient that way. We have heat pump technology. We're using heat pump technology at the Hilltop house, at my house, at the Prairie house. All of those have heat pump water heaters. And then we have heat pumps for our heating and cooling. And then we have induction cooktops. And that's like I've had multiple conversations with people who are like, that's fine, we can go to heat pump, but we're not giving up our gas stove.
So you have forced air for space conditioning. Mm-hmm. What about for hot water, domestic hot water?
So all three of those is a heat pump.
Running off.
So we have a Sandon at my house, which is the outdoor air source heat pump. The other two houses have indoor.
And the Sandon is the one where carbon dioxide is the refrigerant.
Yep.
Right.
Yep.
And that's because I think that there was, and
they claim like 500% efficiency. I'm sure that's them playing a little bit of numbers games there, but
yeah, but those are really high compression, I believe, and that's a technology that we just didn't have.
Yeah.
So switching to the CO2 as the refrigerant means that not only is your electric profile great, but your embodied impact is reduced because of that use of the CO2.
GWP number's zero.
The beauty of electric, too, is to circle back to where we started. You get to use Mother Nature to supplement it at some point, right? Like you build a house, you live in it for a little while, you understand how much power you're using, and then you work in a set of PV panels.
On-site renewables.
And on-site, and you take care of that number even further.
Yep. So we take that $150 a month electric bill that operates everything at my house, and we delete it with minimal cost.
Yeah. And depending on, I know, there's probably listeners out there that say, yeah, solar just doesn't make sense where we live, which, when I talk to like Will King down in Alabama, they're paying like 9 cents a kilowatt hour or something.
We're 11. It's pretty darn cheap.
But where we are, and I'm doing a project on the Cape, or like Martha's Vineyard. Martha's Vineyard is probably like 24 or 25 cents, and the Cape was 21 or 22 cents. We did Dan Roy's house, and he paid for his whole system in, I think it was right around 4 years.
Yeah.
And after that, for the next 16, because he's on this 20-year SREC program, he will have made over like $25,000 in the program. And understand that's making that money on top of paying for the system, never having an energy bill. He supplements his sister-in-law's electric bill because she's on the same grid and you can defer some. And he drives 2 cars on his house.
Yeah.
I tell people he's got the best retirement plan in America.
Yeah, not spend any money.
He doesn't. He drives around and lives at his house virtually for free.
So we drifted a little bit
Plus,
away
he's a
from
cool
heating
guy.
systems, but yeah, if you can make the building really efficient and get the way that heat is created down low, you can do an easier offset with the PV system.
But I think that the one point you just made, though, getting the building loads down low is really important. I mean, Dan, again, I cite his house only because he knows every number and he's given it to me. Right. 2,600 feet, 2,600 square feet. I think his heating load was like 4,500 or something. It was like half
4,500 BTUs for
KBTU. Is it? Is it? No, 4.5. I always get screwed up with that. So
well, it's a question of what the peak. What's the peak heating load that he has to meet with BTUs per hour?
Right. It was half the size of the smallest mini split at the time we built this building, and so we can build a building. My point is, we can build buildings very, very well, far beyond what we need them to be. Actually, if we chose to, and so getting the right house and then applying it helps with those choices because it also helps with the sizing of those systems.
What's kind of interesting too is we talked about heating in Miami. The peak demand for electricity in Miami is not the summer. It's the winter. Because,
They're a bunch of wimps.
Well, what happens is if it gets cold, what type of heat do they have? It's all strip heat.
Yeah.
So when it gets to 32 degrees, everybody is turning on a toaster oven to heat their house. So the peak demand is that horrible day in winter. The other thing that's interesting is that the peak demand for electricity in like Quebec is the summer. Because nobody heats with electricity, but they all run air conditioners. So and utilities have to plan for the peaks. So it may be you say, yeah, but that's crazy. It's only one day. Well, utilities have to plan for the peaks. And so getting the grid clean is not just about what happens on average.
It's like designing a commercial building. You plan the elevators for the 7 and 9 o'clock crowd.
Yeah.
Right? Because that's when everybody's coming to work and you have to plan and solve for that.
I remember the first time I went into the World Trade Centers.
It's like
and looking at those
half
elevator
the
shafts.
floor plan is like elevators.
Exactly. It's a huge vertical building and you walk in and the elevator shaft is like 50% of the floor area.
Yeah.
But
that's,
So are we in agreement that choosing your heating system comes after building a really good house? And then that dictates a lot of your decisions. And then what are your guys' thoughts on my let's just be combustion free?
Yeah, I agree with that. I mean, I strive to get every client to move away and do all electric, which is what we do most of the time. The big holdout is either a stove cooking, and I tell them all to go and try it. Go try it.
And we have a hot plate that we pass out to clients that's an induction hot plate. And I go, if you really don't believe me, put this next to your gas stove and time it.
The people that do move into induction, they're thrilled when they actually
They're like people that do ICF houses, like they just fully believe in it.
full disclosure, we were selecting our heating system in 2001, perhaps. We had a forced air system. And I thought, okay, I'm going to get the best, most reliable, highest efficiency oil boiler, fuel oil boiler I can get.
Please tell me this comes down to cost in the end. You were like, oh, that's too expensive.
I didn't feel comfortable with propane, and neither did my wife, and so we chose a fuel oil boiler. And the bloody thing is like indestructible. So, and I think a lot of people are in this position. It's like
it's here to stay.
We can't switch, or we haven't switched because the boiler is like a really good one.
I can't tell you how many houses I go in, like for remodeling jobs in New England, and you look at the boiler and it's like when was this thing installed? 57? I mean, it's...
Yeah. We have one that's a few blocks from here that we did a renovation, and the thing said like 1952 on it.
Speaking of cool boilers, I remember going into one house out by us to look at. It was a massive boiler, like pickup truck size, again, for this house. It was a fairly large house, but the cool thing was it was auger fed. The coal was fed via an auger from the coal pit. It was a very expensive house in its day.
Burning coal.
Yeah. And so the coal got dumped into a coal pit over there, but it had an auger, so you didn't have to shovel the coal. The auger fed the boiler, which was pretty cool. But anyway.
We just went full gamut there from the most sophisticated CO2 refrigerant heat pump to an auger-driven coal-fired boiler.
Last week I was in a house in New England I went to look at. They still have a coal-fired stove in the kitchen that is fully functional and operating.
Wow.
Yeah. So there's a bunch of these
They probably don't have an IAQ monitor inside that.
Probably not.
Yeah,
but the guy
should.
said that he fires it up every once in a while just because of boil water or something, just to say that.
That's sort of. Have you ever smelled a coal-fired,
I can't
stove
imagine
or something? It's sort of like I love the smell of napalm in the morning type of thing. It is just awful.
Look at him citing Apocalypse. What was that movie?
Apocalypse
Now. Yeah.
I think Meryl Streep's first movie.
There you go.
It's also like the only time that I think Robert Duvall ever looked young on camera. Okay, that's where we're leaving. You want to take us out, Steve?
All righty. So, you find us here on YouTube. Go hit that subscribe button. Follow along. We're all putting up some supporting videos, some really good information. But the most important thing is tell all your friends you just watched Steve, Jake, and Pete. Until next time.
See you.
Have a good day.